Welcome students. This is the second part of topic 5, data communication and networking from unit 2. In the previous lesson, we learned how data is communicated between devices. Now we will go a step further and look at how networks are built and why they are so important in today's digital world. A computer network is simply a group of computers or devices connected together to share data and resources. In the MOS network, we use a client-server model. Let's see what is it. A server is a powerful computer that stores information or services. A client is a user's computer or device that requests and receives that data. For example, when you log into exam department system to check result, your computer, that means client, sent a request and their servers response. This setup allows centralized control, security, and easy resource sharing. To create computer network, we need network devices to connect and manage communication between systems. Let's look at most common ones. Every computer needs a network interface card or NIC to connect to a network. It allows data to be sent and received between computers and network devices. In most modern computers, the NIC is already built into the motherboard, so you don't need to install anything separately. If you look at the back of your computer or system unit, you will see a network port. This is where the RJ45 cable connects. That cable connects your computer to a wired network using guided media, like twisted pair cables. A switch or a hub is used to connect multiple devices inside a network. These devices use wired connections and act as the mediator between computers. But even though they look similar, there is a difference between these two. A hub sends incoming data to all connected devices, even the ones that don't need it. This can cause traffic and slow down the network. A switch is smarter. It sends data only to the correct device that requests it, which makes the network faster and more secure. When we comparing these two devices, hub is use a half-duplex transmission mode, not an intelligent device that sends message to all, and cheaper as compared to switch. A switch is use full duplex transmission mode, an intelligent device that sends message to selected destination, but it's expensive as compared to hub. A router is a smart device that connects two or more networks. It is sometimes called a gateway because it finds the best path for data to travel between networks. Routers often have Wi-Fi built in, so one device can act as both router and a Wi-Fi access point. Now let's talk about Wi-Fi, which stands for Wireless Fidelity. Wi-Fi allows us to connect to a network without any cable, using radio waves instead of wires. That means when you connect your phone to the internet using Wi-Fi at home, you are using wireless data communication. A modem is the device that converts signal from your computer to a format that can traverse over telephone lines and back again. Its full name is modulator demodulator. It converts the digital signal data from your computer into analog signals to travel through telephone lines. We call it modulation. and then converts incoming analog signals back into digital data for your computer. It is demodulation. Today, most routers have built-in modems, especially in home networks. A firewall is a security system for your network. It controls what data can enter or leave your computer or network, just like a security guard. Firewalls can be hardware-based, software-based, or both. They help protect your network from unauthorized access, hackers, and viruses. So, all these devices are mainly needed to create network with computer devices. Now that we understand what a network is, let's look at how computers can be arranged or connected within a network. This arrangement is called network topology. A network topology shows the physical or logical design of the network. In other words, how each computer or device is connected. Let's explore the most common types one by one. In a star topology, all computers are connected to a central device, such as a switch or hub. In this topology, if one computer stops working, the rest of network continues without any problems. When we compare it with advantages, it's easy to manage and troubleshoot. A single device failure doesn't affect others. But if the central switch or hub fails, the whole network stops working. That is main disadvantage of this topology. In a bus topology, all computers are connected to a single central cable called the backbone. Data travels along this main cable and is received by intended devices. When we compared it with other topologies, it is easy to install and require less cable. Low cost for small networks. But if the main cable fails, the whole network goes down is the main disadvantage. And it is not suitable for large networks due to data collision risk. In ring topology, each computer is connected to two other devices, forming a circular or ring shape. Data moves in one direction around the ring until it reaches the destination. Let's talk about the advantages. In the ring topology, data flows in an orderly fashion. It can offer high-speed transfer. But if one computer or connection fails, the whole network stops. And there are difficulties to add or remove devices. Those are disadvantages. A tree topology is a combination of star and bus topologies. It connects group of star networks together to a main backbone cable like branches of a tree. As advantages, it's easy to expand by adding more star branches. Each branch can be managed separately. But if the backbone fails, the entire network is affected. And the installation is more complex. Those are some disadvantages. In a mesh topology, every device is connected to every other device in the network. This creates many paths for data to travel. So, this topology has highly reliable. If one link fails, data can use another path. And strong security and performance also in better levels. But it's expensive due to the number of cables and connections. And complex to set up and manage. Choosing the right topology depends on your network size, cost, speed, and reliability needs. Each topology has its strength and weakness. There is no one size fits all. Now let's talk about the different types of computer networks based on their geographical coverage. There are three main types of computer networks, each serving different purpose and covering different geographical area. These are LAN, Local Area Network, MAN, Metropolitan Area Network, WAN, Wide Area Network. Let's explore each of them with example from real life. A local area network connects computers and devices within a limited area, like room, building, or school. For example, a computer lab in your school, a Wi-Fi connection at home. LAN are fast, easy to set up, and low in cost because they are small and manageable. A metropolitan area network is larger than a LAN and usually covers a city or group of buildings. Examples: a university with multiple campuses, bank branches within a town. A MAN connects multiple LANs and is typically managed by an organization or government. A wide area network is the largest type of network covering countries. The best known example is the Internet. WAN connects many LANs and MANs using telephone lines, satellite or fiber optics. They allow people from around the world to share data and communicate. Why do we create networks? The main reason is to make our work easier, faster, and more efficient. But no system is perfect. While there are many benefits, we also need to be aware of the challenges that comes with networking. So when we talk about the advantage of network, we have control central softwares and less storage space. As advantage, we can share our resources. Electronic mail facility and can connect at any time, anywhere, and the security. But there are some disadvantages also. There are some security issues. And if there is a breakdown, think about it. And virus attacks. Breakdowns of computer devices and special we need training requirements. So this marks the end of Unit 2, Fundamentals of Computer System. We have learned about input-output devices, memory ports, and data communication and networking. So see you in next unit. Thank you.